I'm Marshall, and I'm the old bloke in the shed. One of many, I would think. I've got a video coming up after this for you, and I hope you enjoy it. This is my newest, oldest machine. Made in 1919. 939, number 939 made. Corona, I think it says up there. It's a pillar drill. It's got an MT4 chuck. It's got a 3-speed power feed down. It's got weighted, you see the little chain just there. Well, that goes into there, the column, and there's weights dangle in the column. It's powered at the moment by this 2 horsepower motor and a line shaft belt, but I'll probably end up changing a bit of that. That table can be wound up and down. I don't think it turns sideways though. No, it can't, because it's... Oh, the whole table might revolve actually. I kind of bought this without really getting up close to it. So, that's what you do. So that's going to be a bit of fun. I bought another thing, I'll show you later. This is me getting the 1919 pillar drill in. It was supposed to go over there, but it ain't going over there. It's going over beside the lathe now, which caused me a few problems, but we'll work around it. I've just had to take that acro prop and push that beam up to get under it. Once I get it back far enough, I've got it in the pallet we actually brought the Bridgeport in on, and it's been strengthened, that pallet. So if I can get it under these beams, then I can get the forklift in and lift it up from above, and we'll get the pallet out, get it down on the floor and some boards under it to level it. It's some machine. It weighs quite a lot. It was beginning to pick up the front of the David Brown, but it's getting past. I don't know how I got past those beams. It somehow got past them. So I shall get it in place and let you see once it's in place. How to get a very heavy antique drill into place. I had to take one of the forks off so I could get in past all the beams, but at the moment I'm just trying to get the pallet from under it. I got it in place and levelled it off with some boards. That's not where it's gonna live. I'm going to be moving it later on. I've got a plan. We'll do a quick run through it. So we have got a line shaft drive here with 4 pulleys, so you get 4 speeds there. This here, you can move back and forth, and you can get direct drive, so that gives you 4 faster speeds, but you have to stop it to move it. At the moment it's running off the shaft, on a gear there, on a gear there, and on a gear there. But when you pull it this way, it's direct drive. It has automatic down feed. That engages the down feed, and it's got, this gives you 3 different speeds for the down feed, and then you can move that, and when it comes down it'll disengage the down feed. That, I don't know what that does yet. That, you need to put that in to engage the down feed, and the handbrake lever thing is what locks it in place, but that's not working at the moment. I've yet to find out. And it's got this handbrake mechanism, but I think it's something wrong inside. Flip that. So that drive, they both come down as you bring the whole head down. The table revolves, you can lock it, And you can also wind the table down with that handle. It will go right down that ratchet. You can see it there. So the motor's there, but I'll have to move that because if you get flooding, that'll end up underwater. I'll bring that up somehow and then figure out what this does. It's not like you'll get a manual for this thing. Love it. So there you go. Quick run through the 1919 Corona power drill. I think it's Corona. Anyway, that I've got it used to old Fortune Mega Dynamo on the function. I've got a few of this in there, I can put it in the dynamo. The motor's still free floating. That seems to work, and we've got new lights in the tractor shed. So I've got one above the Bridgeport here, so let's see what the flicker rate's like on it once we've looked at this video. With a few changes, which you might have seen in an earlier video. So let us say we've got new light there, new light here, new light over there, and got the monster drill finally in its resting place, and the motor's been lifted up about 2 feet, so it's above the flood level. Caused a lot of problems, but so that green bench you see beside there, that cut it down and put it in sideways, so that holds the vise for it, and I've got an XY cable I can put on, but it's very heavy, so I can lower that down and swing it around to the side and then just drag it on. The hydraulic press, it'll come out of there no problem. If we pull it forward and then go that way, it'll come out. The welder's under the jacket there, and the jack's under there, so that's keep away from the belts. And the original pillar drill, I got it from an old friend, and I was sad to part with it, so it got put back. Whether it'll get used much or no, I don't know, but it might be handy for something small. So the plan at the moment is get this chuck, find the centre, and then put 4 M8 studs in, so we can bolt it to the centre of that big drill, and then we're going to be boring out these cogs for the ring roller. This is the ring roller. It will be coming up in a future video, but it's been lying outside for about 20 years. We'll drill them out in the big drill there just for fun. You could do it in the lathe, but I thought I'll try them. They're a bit unusual. Let's see it in that one. The rollers have got a square through the centre because this is a drive roller. I'm wondering if they forged a centre bar and then cast the cast iron round it, because when it cooled it's obviously going to shrink, isn't it? So it'll be really tight in there. So we need to sort this bit. So whether we just bore a hole right through and machine out a bit there to weld a new one in, I'll have to think about that. The biggest broken cog goes on here, like 2 foot diameter. That was the hardest one to get off, because as the puller was pushing on there, it was mushrooming it out, so it was kind of fighting against itself. So in the end I just got it red hot, the whole centre of the cog, and hit it with a hammer till it came off, and that worked. This one you can see it's square in there as well. I think that square goes all the way through. That's why I think they cast it on them. There's 3 rollers. Those 2 are driven, and then there's a pressure roller goes on the top, which I don't know if you can see. It's in a lathe at the moment. I've cleaned up one side and I'm just tuning up the hole through the middle. I went through a drill, but don't know how true it is because long drills tend to wander sometimes. So I'll flip it around the other way. And anyway, let's find centre of this. It keeps getting cold in here. It's winter, I suppose. We'll need to make sure we can find holes. So there and there, which puts us in there. Just trying to work out where we can put the holes. We'll just do two, that'll be easier. So we go there, we'll get a hole there and a hole there. That should be enough. It'll bolt to the revolving table. I've got it centred. It's only reading the y-axis when you're coming this way. So I found the centre coming this way. We'll just use the x-axis for now. Make them both the same. That ain't gonna work. Forgot about the screwy bit. However, we can turn it round in place because it'll still be in the same place, won't it? Missing it there. That should be good. Will always be the same distance from there. 95. 7. 100 looks like. 100, too close to the edge. Right. Let's make it 96. 96 millimeters from the centre. .6 millimeter tap and drill, 8.5 millimeter tap and drill. About there. The clock changed last night, so I'm not at fault with my times. Went back an hour. The clock might have changed, but my biological clock's still the same. Okay. Right, back to 96 at the other side. I wouldn't mind getting a new DRO system because I could get a 3-axis one then, but they're not cheap. Plus I need exploring Uncle Jim to set the thing up for me, which he would do. Now, tap that. Tap. I seem to think that cast actually taps better when you do it with a machine than doing it by hand. But I could be wrong. Left a bit behind. That's tightening. Right, that's it. I'm just going to do 2 because I don't know how accurate it would be with the other one with the DRO not working. Well, I suppose you could measure it out and do it somehow. I'll put the studs in so I know it's in the right place. I haven't been doing much tractor stuff lately with that drill arriving and rearranging stuff and getting new wiring sorted out and getting beams moved. That was yellow on the end, that means it's 8.8 hardened. Now hopefully this will sit bang on centre now. This is the original 3-jaw for the Edgewick lathe. This came with the lathe. I've got a 4-jaw as well that I can get to work again because it won't be spinning, it'll just be stationary, so not matter. There's always something broken. Right, I'll get this set up and I'll bring you over to the... I'm going to call it 939 because that's the number on it. I'm assuming that's the number it was built. So hear me referring to 939, it's the big pillar drill. Well, after all that, the cogs are too big to go in that. So I've got a vise I bought, see if it's big enough. I'll get it mounted up and then I'll bring you back. To lock the table from rotating. Right. Drive. I think I tightened that up enough. Oh me, I'm learning. The fastest down speed we'll try it on this one. It's a lot slower down speed. Oh boy, wobbles a bit. Where did everything go? That's speed 1, that's speed 2, and that's speed 3. We started on there, we shall left it on there. Just shows you the force that can put on there if it can spin that table when it's locked. So what happened, it caught in the keyway and started throwing everything round. That's how accurate we drilled. Not too bad. So it must have just caught that keyway and pshoo, off it went. I'll try and get that key out of there now. Round 2, go for a battle, I'll probably die before I finish it. We're not quite centred. Right, off we go. Not quite in the centre, but it'll be okay. Here's the drawing. You can throw it out to a smaller size and keep it close to